Hello, my name is Keelan Roshad. I've been employed to talk to you about IoT, so I'm just going to go over what IoT is, its appropriate use in software development, trends, advantages, disadvantages, and then I'm going to review the architectures, frameworks, tools and hardware that go along with it then, okay? So just to jump right in, what is IoT? It's a question I frequently get asked like daily. So just to give you a basic description, IoT stands for Internet of Things, and this is where devices that we use daily are connected to the internet to take in our data and then just give it back to us in an efficient and understandable information then, just to help us improve daily tasks, so certain scenarios that I'll go on to later then. So its appropriate use in software development. This is simply when a company develops an application or monitoring devices that go along with the IoT device. This could be anything from algorithms just to define the basic goal or the usability of the IoT device, and then just display that data that it takes in in an understandable and appropriate manner for us to digest and consume. So just an example of that will be a black box that monitors a car, determines the driver's usage, speed in, braking, etc. And then it'll take in that data and then compare it to certain roads, certain speed zones and all that, and then give you the information on whether or not you have been speeding, you have been braking too hard, accelerating too hard. So yeah, it just helps you become a better driver and constantly monitoring your performance, and it does give its benefits as well depending on the company that supplies it. So just moving on to forms of trends. I have two diagrams here just to show you briefly, and they are really small, but I will provide another link to them. And basically the diagrams just show the trends in security, system living, and then the other diagram shows then the services and how a general IoT service can be personalized and become more efficient for you then. So just to quickly go over that, assistant living, you could have lighting back in the I say back in the day because we have moved on quite far from that. So ages ago you used to be able to turn a light on by a switch. Then it moved on to clapping, and now it's moved on to telling AI to turn certain lights on and off in your house, and then it's developed its own patterns to turn the lights on or dim the lights in certain scenarios that are used to your daily habits then. And then the services then, the other diagram that goes over, so a general type of, with the AI example, the general service then that it provides is that you ask it a question and then it gives you an answer. So then to make it more personalized, rather than just asking a question, it'll give you a more substantial answer then related to your type of scenario. So in the morning you could ask, what's the weather? And then it'll give you general location and the weather state in that location, such as it's raining. So to make it more personalized, it'll be in your area, it is going to rain at this certain time, and then it'll get better or get worse throughout the day. It might even advise you to have the addition to take an umbrella, or to wear less clothes if it's going to get hotter throughout the day. It just makes it makes the experience more personal and better for you. Then you feel more comfortable with the device talking to you, I guess. So just moving on from that then, more recent trend, I'm going to stick with AI. It's typical AI in hive houses. The development of using AI started with phones, with Apple Siri, and now it's moved on to the watches, TVs, it's cars, it's everywhere. So it started off back in, I believe it was 2011 they developed Siri, and then a couple of years later Amazon developed their Echo Dot, that's called Alexa, and then a couple of years after that Microsoft developed Cortana. They all do the same basic principle, but they're all a bit different. They relate to different things. For example, Microsoft is more business orientated because that's the type of company that it is, where there's Apple Siri is more related to stuff that's on the go, because the devices that they use, the devices that the AI is programmed in, are for on the go stuff like watches, phones, that type of device. So they all do the same thing, and they all give you the same information, and they all work within a thing called IFTTT, and it's just different types of ways to connect and gain data from you to give you the better experience overall then, okay? So just going straight into advantages now. So some basic advantages of IoT devices are that it saves time. So, sticking with the AI example, rather than going up and flicking the light switch off, you just go turn the lights off, the lights are off. It's better living as well, so, your daily lives are at ease. If elderly people who can't walk struggle with this, they might, gain more benefits out of that type of technology, because it saves them from getting up, or someone else to get up for them to, sort how their lives are. Manages tasks very well. So, like I just said, sticking with the AI, if you tell to do stuff, it'll manage that task, no problem. It might then, the only difference, difficulties, not differences, that it has is with accents. I know the Amazon Alexas, they don't respond well to people with Scottish accents, so that that could be a disadvantage as well. But overall, the percentage everywhere is probably quite high. Otherwise, the product wouldn't be available to buy on the market as easy as it is. So going into disadvantages now, data collection, like I've kind of just touched on briefly, is that when you tell AI certain things or put it into certain devices, your data, that is, your own personal data, and it builds it up and gives it back to you in understandable information. But, if the security behind those companies isn't all that great, then you're putting all of your data at risk to, be hacked, to be used, and, turned against you, essentially. An example of that is an IoT device today could be considered a phone. So on my phone now I have the mobile banking applications, and they basically help me pay on the go if I forget my wallet or if I lose my card. It's just another way to pay, and it's pretty, it has its own benefits. It's quicker, and you don't get receipts, so it's not wasting resources. And but if the mobile security was quite weak, my bank account details are on there, so along with my personal information, phone numbers for other family members that I have, my mobile banking applications on there, and if that goes, then my banking details are everywhere. How much money I have, just bank statements in general, where I spend my money, so you can pinpoint to where I actually live. It is quite scary if it does get hacked, and it is a huge disadvantage if that certain scenario happens. Another disadvantage then is compatibility. It does unfortunately have its disadvantages of even though IoT devices are connected everywhere around the world, if they're done by different companies, then they might not have or share that compatibility against each other. So if I have, for example, a Google docking station, which is it's Google's version of Amazon's Echo Dot. It's almost the exact same thing with different AI running. If I wanted to connect my Apple Watch, for example, to my Google Dot or Google phone, I couldn't share that data with each other, even though they both do the same thing. If I went for a run, for example, and the watch told me how fast I ran, where I ran, how long I ran for, I couldn't share that data to a phone that isn't of the same brand. So yeah, that's just a disadvantage, because you would like everything to connect, so it's a lot easier. You could do that. You could take phones with you, but it may not be as accurate if you're doing certain exercises. So yeah, it is just another disadvantage. So moving on from that then, I'm just going to go into the second part then, the review of architectures, frameworks and tools. So just to start off with then, I'm just going to go into architecture. The architecture of IoT is most likely going to relate to the OSI model. The OSI model is an architecture in and of itself to explain how certain aspects of computer programs or devices, like how they work. Each computer or device works on different layers. Just to break it down into simpler terms, to find the best way to identify issues, and also different layers will relate to different scenarios of a computer. So for example, just to break down, is the transport layer. So if a device has a transport layer on it, or a program, it'll connect to a computer through a port. So for example, if I wanted to send my pictures from my phone to a computer and I do it through USB, the transport layer of the application on my phone will help stream the data to my computer with the transport layer or transport file transportation protocols inside of the computer to help it flow from one device to another. And IoT mainly focuses on the following layers: security, storage, pre-processing, and monitoring. So as you can kind of see, the examples I've given you, you can see how they relate into that. So IoT, the security layer has got to be there because it's got to protect your personal information. The storage has got to be there because whatever you put on your device goes up into the cloud and it comes right back down to your device. So the storage has got to be top notch. It's got to relate to that as well. Otherwise, if you didn't have anywhere to store it, then what would be the point in having the device? And then pre-processing as well. That covers it's constantly working, it's constantly monitoring stuff as you're doing it, and then sending it up to the cloud, and then the cloud's processing it, and then just giving it back to you in understandable information. And then monitoring as well, exactly what I just said. It's, monitoring constantly what you're doing all the time, where you go, what you do, how you do it, and sends it to the pre-processing to give that information back to you. Okay. There are many IoT platforms and APIs on the current market due to the growth in trends of IoT, which I've just explained. I have found an all-round basic framework that requires you to have some idea what you're doing. It's called Node-RED. It's a visual tool for writing IoT connections and integrating them simply. It's built on JavaScript, follows installation and integration flowcharts. It's reliable, and there's loads of tools online and tutorials to explain how to use it properly and efficiently then, okay? So just some key points is that it's easy, it's beginner friendly, it uses color-coded boxes and wiring connections to visualize, what you're doing, and it runs on a wide range of stuff then, like cloud, you can download it or use it on the web if you really want to. So just to explain what it does, if you draw a diagram of where you want your IoT device to be or where you want it to connect to, you draw that up then and you simply give it to the Node-RED software and it gives you back a finalized version of that. So it appears more professional. So if you need investors or outsiders to take notice of what you're doing and that you've got a proper idea in your head of what you want to do, this is a good way of visualizing it for other people rather than just having an idea in your head then. So I'm just going to move on to tools. So the tool that I found is Windows IoT. It's quite a recent tool, but it helps you carry over the code into a cloud storage and gets all your results within the Microsoft packages. So if you code with a program language C#, it's quite easy to do. There's loads of coding examples and tutorials online to help you create certain scenarios. You can do that with Microsoft's Visual Basic or Visual Studio's software, and then you can use the IoT then to take that code and put it straight to your IoT software and get the cloud storage running. And it's a really good tool of to get an idea going straight away. A Raspberry Pi then is another tool, but it's an actual physical development tool with code and software to just help you program your very own device or prototype. It's essentially just a tiny computer with ports and sensors and buttons and other parts to help you, code a device like ready. You have a working prototype to help you again visualize what you want to do. You might find that it's too hard and you can't do it. So if you don't have the expertise, you can take it to someone else, and at least you've tried. You've got a little prototype of roughly what you want to do. So it's got all different types of ports that come along with it. So they'll help you kind of there's different ways of connecting to that device, and you can get a rough prototype going of what you really want to do then. So just to go over some of the hardware that's found within IoT devices, we've got CPUs, which the central processing units. They take in the data, sort it out, and then give it back on the device itself, or it'll help process the data to connect it somewhere else and send it off somewhere else. Then it's kind of like the brain of the device. It'll help you keep track of everything that's pressed, all the buttons that are pushed to give you back the data then on an interface on that specific device. We got MPUs then, same as a CPU, but it's a microprocessing unit, and it does what a CPU does, but at a really small scale. So it'll take some of the little transactions, like for example, if you got a speaker that connects to different devices over Bluetooth, the microprocessing units then will kind of take over the simple controls of up and down volumes and so on then. Sensors, that's the main IoT hardware. Track where you go, GPS sensors just for picking it up, motion sensors. There's also one called an accelerometer, there we are. Gonna start again. Called an accelerometer, and that basically determines what angle the device is at when you hold it. So if you hold a phone like that, all the information is displayed this way, and then if you hold it that way, all the information on the phone is displayed that way. Those are just some of the basic hardware, installations to help you, get a prototype going, and some of the things that you want to look out for when you do, use come to building an IoT device, because that'll help you a lot with really understanding what's going on, and you don't think you realize how much hardware you need on an IoT device, but there's loads that come with it. So I'm just going to move on to APIs now. They're called Application Protocol Interfaces, and this is basically how a user accesses the IoT device information that the IoT device makes. So I found an API called an IoT ticket, and I have a diagram to back up everything here. So I got a diagram here that shows how you start off here, how it normally occurs. So you go through an API that connects to different types of companies, different types of tools. It goes up into the data processing and then just sends it back down then. So this is how it's normally occurred, but with the IoT ticket, it goes from here to the API, to the data processing, to the IoT ticket that deals with alerts, notifications, other applications that it connects to, and analytics, and then it gives you it back then. So there's also some benefits here, but I'll also provide a link for these, so you're not going to miss out on the information that's there. So just to briefly go over that diagram, how it usually happens was, you'd have a device or an application on a device. It'll go up to an API, and then the API will connect to different companies, because no other company had done what IoT Ticket does. They all did different kind of jobs, and it's like the API's job was to connect everything together to give you the data back in an efficient manner over different companies. And it could have been a mess, because there's lots of benefits and drawbacks from here. But so if you connect into different companies, then the security risk is a lot higher, rather than connecting to just one specific company per there then. Okay, so I'm just going to move on to how the past things I've just talked about help solve specific problems. So just going into the layers that I mentioned earlier, this can help solve problem-solving issues. So if you have a problem with a certain section, you can have a look at the different layers that I mentioned earlier, the architecture of the actual IoT device. For example, if something isn't sending over properly, then it's in the transport layer. If something is not displaying correctly, it's in the physical layer. It's in the display sort of section. So it just helps you find those problems a lot quicker. But try and keep it organized. Don't have lots and lots and lots of different layers, because then that's more problems separated. You might find that a problem comes across 2 or 3 layers. So if you have about 4 layers, simple enough to find it in. But if you have something up to like 20 layers for all types of different scenarios, that's a lot of ground to cover. So you might not have the manpower to sort it out. The framework that I mentioned earlier, Node-RED, that solves the specific problem of just usability. It's a simple to use framework. So if you are really struggling with the process and certain IoT applications, or you're just struggling to virtualize the work you have, it helps you put in a nice tidy diagram. Same with the hardware as well. That like sensors cover the problem of how do I get the device to tell if it's upright. Like the phone example I mentioned earlier, a sensor will sort that out, accelerometer will sort that out as well. If you need the device to carry its own tasks, the CPU, the MPUs, they're all there. Even if it's just a matter of you need the device to tell you something, just put a screen on it, and that'll tell you, sort it out straight away. And then the API that I mentioned as well, that generally sorts the problem of connecting to all these different companies, sorting all the big data and the analytics. It's all in one place. So it does have its disadvantage of, if it gets hacked, that's all the data down the drain. But then it's in one secure place rather than across several different places. It increases the efficiency, it saves on all the costs, and it's just a better service in general. So if you have a problem with, if something's down on one of your branches, you have to go through, different customer services to get to the problem, rather, just to, sort something really simple out. Rather, you can just use the IoT ticket, and then if you have a problem with, for example, the dashboard, it's not displaying the data properly, it's just one company, one phone call, and then it's sorted, rather than trying to connect to different companies and sort out, the data that way and the problems that way. That's really all I have for you. Me and Alex, Alex and I, we've collected a lot of data, research to explain to you all the different types of IoT trends, different types of IoT devices, the hardware, and how it's all built and how it's all structured. So hopefully we give you a really good understanding of how everything works. If you have any other questions, just please refer to our documents that we have. Again, I'll be supplying all the pictures, all the diagrams that I found through different companies online. They'll be on file for you, and if you're in the meeting that we're displaying this document on, I can give you paper copies as well, so you have a rough idea of how everything works. Okay, I've been Keelan Rocha. This has been my IoT device documentary. Sure, Alex will say the exact same thing as I did, so just thank you very much for listening, and goodbye.
Hello, my name is Alex Thomas, and today we're going to be talking about IoT. What IoT is Internet of Things, which uses a computing concept that describes a scenario where everyday physical objects are connected to the internet and can identify themselves to other devices or processes via an IP address. An example of an IoT device being used in an everyday scenario is the Hive, which is controlled by which controls your heating, in your home through an application on a smart device to help control it. This will mean that you can see what temperature your house is at normally, set it to, if it goes below a certain degree, then you can have it automatically turn on your heating, or it'll tell you, it'll ask you, do you want to turn on your heating, show you how much gas you're using at a certain point, how much energy you're saving or losing depending on how much you're using it. But other things that could also come from the IoT devices are smart devices. That will become more a thing. Smart devices will become more commonplace. So this means that more, for example, Apple Watches will be more used for healthcare reasons. So see if your BPM's higher than normal, or if you're stressed, or if you need an ambulance, etc. That can be used as it. More marketers could use IoT to help them find out what the best selling product is in their store at the time, whether they need to start making cuts on other products, or if they need to start just looking in new places to start selling. Which then leads into the fact that you'll see more IT in retail over time, and obviously the advantages are the communication, the automation and control, the monitoring, the time it can save rather than looking through all the data yourself, and or hiring someone to do so, which means you'll end up saving money. And obviously automating of the daily task leads to better motivation of devices, which means that more motivation around the workplace which means better outcome, faster outcome, and so on. Some of the disadvantages, or it can be real complex depending on how far you want the IoT device to go. Privacy and security side of it, if it isn't set up correctly, can lead to big failures. The safety of the IoT device can it impact you in any different way? Could it damage your health? Could it put you at risk if you're not using it correctly? And also, technology takes control of your life then at that point, because of the dependence you need on that IoT device. You're going to end up not wanting to do the stuff yourself. You're going to start losing the control of your own life and ended up just leaving technology take over. But as Keelan has already mentioned all that, I'm going to talk to you about some frameworks which I found which was the top 3 open source frameworks that I found, which were KAA IoT, Zente, and GE Predix. I can talk about the KAA IoT. It is one of the most efficient and rich open source Internet of Things cloud platform where anyone has a free way to militarize their smart product concept. On this platform you can manage unlimited number of connected devices with cross-device interoperability. You can achieve real-time device monitoring with the possible of remote device provisioning and configuration. Basically means that you can set up a limited amount of different projects, if you wanted to start a project on an IoT device that you've been thinking of. As long as it's configured properly, then you shouldn't have no problems. But again, it's an open source cloud-based computing, so you would need internet access. So the downside to that, you're always going to need internet connection to access your projects. But if you have internet access, you're not going to find this a problem. But the device you are using to access the cloud from might not be able to support the full intent of the service itself. Zante is a server orientated platform that has been built around Node.js, REST, and a flow-based reactive programming development facility linked with the Syrian Hypermedia APIs. They relate to the cloud service after being abstracted as REST APIs. These cloud services include virtualization tools and support for machine analytics tool Link Splunk. It creates a geo-distributed network by connecting endpoints such as Linux and Arduino Hax boards with platforms such as Heroku. Predix is a platform which is placed where industry runs as a scalable assisted genic data foundation. It is a comprehensive and secure application platform that can run, scale, and extend digital industry solutions. Leading IoT capabilities, this platform delivers shared capabilities that industrialized application require. Assist connectivity, edge technology, analytic and machine leading, big data processing, and systogenic digital twins. Built once, developed anywhere. Designed as a durable application platform, Predix platform is optimized for high volume, low latency, and intelligent, intensive data management and analytics driven outcomes. Driven results with the Predix platform. Predix Edge, which is normally what most people buy, which is the big industrial state package. It is used just to basically build it once, as I said, and use it anywhere. Then, so if you think of a project in your house, you check up on the cloud, go to work next day, you carry on working on a project, you show your manager, you show whoever, and it's really a really good platform if you're in an industry based job that you're looking to help improve by adding an IoT device, such as, for example, if you're working in steelworks, you're working on the furnaces, and someone from HE wants to talk to you. You could have a location device such as a watch or a clocking device somewhere, which once you put that in, you put like a watch or some sort of tag on your body, so if they need to contact you, they can see where you are, see how long it should take you to get to a certain place. But the downside to that, some people might not be willing to do that because obviously it's privacy. Some people might just not like the fact of being tracked everywhere. But the upside to it is the fact that you know where all your workers are. So if there was, for example, a fire or explosion, because obviously it's steelworks, you know if someone was tracked because of the IoT device, as long as they were wearing it, or if it was just a planned routine fire drill, or whatever sort of drill is going on, you know who's sort of where, and if they could make it in time, or if you need to add more exits or more safety measures in place, just in case any of these drills were to happen. And yeah, that's going to be it from me. I hope I've done my part, and thank you to Keelan for doing the first part of the documentation. And if you've got any questions, as Keelan's already said, we have paper documentation going around, or you can refer to our Word document, which shows you all our the Gantt charts, our methods, our references to where we've got all this information from. And that's it. Thank you very much.